How do we know we'll have 4 decimal places?
Because there's 2 decimal places here and 2 decimal places here.
Now, same thing, still asking for how many decimal places would I get? If I have 12.43 multiplied by 1.50, would I still get 4 decimal places?
No,
Because?
it's 1.5 technically.
Correct. Because
Otherwise, it'd be like 1.5000000.
yeah, no matter how many zero you place over, like after, it doesn't really matter. But here will be one thing that if I change. If I place 0.000000001, it will change the whole thing.
Yeah, it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It'd be 11 decimals.
What does it mean? A factor.
For example, like the greatest common factor would be 3, because for 15 you write like 1, 3, 5, and 15 because they all go into 15.
Okay.
And for 36, 1, 3, 6, 12, and 36.
Mm-hmm.
And the greatest factor is 3, which I think is the only one too.
Yep, that's correct. Okay, I realize that both of you are using trying to find all the factors in each, right? Like for example, 51, you'll try to break it down with 1, 3, and then 17, and then 51, right?
Yeah.
But you can do short division.
I only learned long division and I never learned short division.
Oh, golden opportunity then. Okay, let's use 85 actually. Okay, let's think about the greatest prime number that 85 can possibly be divided. So divided by 5, what would the number be?
17.
Correct, we get 17. Okay, so 17 is the prime number, correct? So that's when we stop. So we know that 85 would equal to 5 times 17. Or, of course, 1 times 75. Let's move on to something that with more different 2s and 3s. So let's try to do that. 60 and 140. So let's do 60 first. What is the possible largest prime number that it can be divided from?
3.
Okay, let's try 3. Okay, 3 is a prime number, so we can do that. Okay, so 60 divided by 3 is?
20.
Correct, 20. So we write 20 down. Okay, what is the next biggest prime number that 20 can be divisible from?
5.
Okay, so we write down the 5 right here. So 20 divided
4.
by 5, correct, 4. Then what is the next prime number that 4 can be divisible from? So 2, right? So we get a 2 here. So over here, we get a upside down cake we get a 3, 5, and 2 2s. So that means 60 equals to 2 multiplied by 2 multiplied by 3 multiplied by 5. It can be whatever order you want. Okay, let's do 140 together. Same thing, I can only divide it from prime numbers. Okay, 7, so I would get a?
20.
Correct, 20. Okay, so same thing right here. What should I do?
Then you write a 5.
Uh-huh.
4. And then 2 and 2.
Correct, so 140 equals to?
7, or 2 times 2 times 5 times 7.
Yeah. Okay, we says that GCF stands for greatest common factor. So we only look for the thing that they have in common. We have 2 2s in the 60. We also have 2 2s in the 140. What other thing do they have in common as well?
2 5s.
Yeah. Oh, okay, and 5. We just multiply the common one. So 2 times 2 times 5 would give us?
20.
Mm-hmm. And that's it. Their GCF is 20. Now, same thing for the LCM. You can do exactly the same thing. We still look at the prime factorization. But since we're looking for the multiple, any idea what we should do?
7 times 5 times 2 times 2 times 3.
Yeah. We're looking for everything. So we know that they have in common, right? After you see the common thing, neglect one set. So over here, in order to find the LCM, I only write down one set of what they have in common, just like what we did for the GCF. But I also include the number that we neglected before when we're trying to look for GCF. In other words, you can think of least common multiplier as multiplying everything as long as they're not repeated in 1. Then that's it. That will be our answer. Make sense?
Yeah.
Okay, great.